Okay, now we want to talk about solving some problems with inverse trig functions. And on the test review, these are problems 24, 25, and 26, and I guess 27. So if I look at let's actually look at number 24. So we're asked to find the exact value of this. No decimals. This is how you write an inverse sine function. It looks like it has an exponent of -1, but that is not an exponent. This -1 here is just a way that we can indicate that we're looking for an inverse trig function. There's actually a second way to write an inverse trig function, and it's called the arc sine. So the inverse sine of 0 and the arc sine are the same thing. And actually, the answer to both of these is simply going to be an angle. That's why I put theta here, because theta is what we normally use to indicate an angle. Now we've actually already been solving inverse trig functions, although we didn't call it that, because, let me write this problem again, and then let me actually write out the question you need to ask yourself when you're trying to solve this kind of problem. And here's what I ask myself. I say, what angle, and I'll actually call it theta, so that's what I'm trying to figure out. What angle, theta, when I take the sine function equals 0. Okay, that's the actual question I would ask for this problem. I'm looking for an angle, so that when I take the sine of that angle, it equals 0. If you wanted to, you can rewrite an inverse trig function as the sine of theta equals 0. So we're saying, so what does theta have to be? So you got that? Whenever I see an inverse trig function, in my mind I'm saying to myself, an inverse trig function is always going to be an angle. It's going to be an angle. So when I see this, I ask myself, so what angle, if I go take the sine of that angle, equals 0? Another way of saying this, the sine of what angle equals 0? Now what's interesting, so that part, I think hopefully is easy to understand. We've sort of done that before already. We've sort of done problems where we had to go figure out what the angle is that gives us a certain sine function. But the tricky thing is, with these trig functions, there is a limitation on the allowed angles. When I go find this angle, I can't just choose any angle on my unit circle. For instance, for the sine of theta, when I go looking for my answer, as it turns out, I can only have an angle that is between negative pi over 2 and pi over 2. If we think about the unit circle, we don't work with negative angles a lot, but you recall a positive angle starts at the x-axis and goes counterclockwise. A negative angle goes clockwise. So negative pi over 2 is actually down here Negative pi over 2 is right here, and then pi over 2 is up here. So what we're really saying is this left-hand side of the circle, of the inner circle, are the allowed answers for an inverse sine problem. My answer has to be over here somewhere. So for instance, let's go ahead and think about the problem we're now doing. The question is, what is the angle where the sine of that angle would be 0? And actually, on the unit circle, there's two places. I would say when theta is 0, and also over here when theta is pi. So these are the answers we would get from just thinking of the unit circle, but now we have to take into account we can't just choose any answer. There's a limitation on the angles. And the limitation is, hey, the angle has to be between negative pi over 2 and pi over 2. 0 is fine, but you know what? Pi is outside this allowed interval. So really, we cannot give pi as an answer. There's actually only one solution. That would be the angle 0. Let's do a few more examples so you get a feel for this. This actually is not on your review guide, but I just want to do a couple more examples so you get a feel for this. How about if we're looking for the inverse sine of 1/2? So once again, what are we doing? We're trying to find an angle that when I take the sine of that angle, it equals 1/2. So basically, I'm going to my unit circle and trying to figure out where in my unit circle is the sine 1/2. If I think about it, the normal unit circle, the sine 1/2 would be here at pi over 6, and over here, and with the normal unit circle, we call this 11 pi over 6. Well, if I tried to give that as my answers, oh, that's not correct. The sign is negative here. Instead, the other answer is 5 pi over 6. Hopefully some of you caught that when I was saying this. So really there's two possible answers when I'm thinking about the unit circle, pi over 6 and 5 pi over 6. But then when I look at my limitation, once again my limitation is the angle has to be between negative pi over 2 and pi over 2. Pi over 6 is okay. 5 pi over 6 is actually outside this interval. So once again, there's only one answer, pi over 6. Let's do one more, just to show you one more little twist. How about if I said, let's find the inverse sine of negative square root of 2 over 2. What does that equal? Or I could call it theta. Same routine. I'm thinking to myself, let's go find an angle, and I'll use the unit circle. Let's go find an angle on the unit circle that when I take the sine of that angle, it's negative square root of 2 over 2. So I go back to my unit circle and I say, okay, where is the sine negative square root of 2 over 2? And actually, I know down here, at this point, this is like 5 pi over 4. The sine is negative square root of 2 over 2. And then over here at 7 pi over 4. So at first glance, once again, when I'm thinking of my unit circle, I would think these might be the answers. But then once again, I check my allowed angles, and as it turns out, 5 pi over 4 is not allowed, it's not okay, and neither is 7 pi over 4. But if I look up here at my circle, 5 pi over 4 is pretty obvious. It's over here. It's not in the allowed area. But 7 pi over 4 is. It's over here. So why is that answer not okay? Well, the trick is I've written this angle as a positive angle, right? All the way around. 7 pi over 4. What I need to do is, instead of making this a positive angle, I need to start here and actually look at it as a negative angle. Because as a negative angle, it's actually negative pi over 4, which is actually in my allowed interval. So when it's all said and done, my answer is actually going to be negative pi over 4. So for inverse sine functions, if the angle you're looking at is ever over here in this fourth quadrant, that point is your answer, but you need to write it as a negative angle. If your answer is in the first quadrant, it's just a positive angle. If the answer is in the fourth quadrant, it's a negative angle. Now let me quickly talk about the other trig functions, other inverse trig functions, inverse tangent and inverse cosine. Let me actually do tangent next, because tangent and inverse tangent and inverse sine have the same limitation. In other words, if I'm saying what's the inverse tangent of -1, just like the inverse sine, that answer, that angle, has to be between negative pi over 2 and pi over 2. So if I was given this problem, so I'm looking for an angle where if I go and take the tangent of that angle, it's -1. And since tangent, if you remember, tangent of an angle is sine over cosine, I'm really looking for some place on the unit circle that the sine and cosine are the same value but have the opposite signs. And if you remember, this case would actually be over here at 3 pi over 4. In other words, the tangent of 3 pi over 4 is -1. And then also, the tangent of 7 pi over 4 is -1. So you would think initially that these would be your answers, but as it turns out, both these angles are not in my allowed interval. 3 pi over 4 is not even allowed, because once again, just like the sine, the inverse tangent, my angle has to end up in the first or fourth quadrant. 7 pi over 4, once again, here we go, it's in the fourth quadrant, but it's outside my range, because what I have to do is I have to approach it as a negative angle. So theta would actually be negative pi over 4. And now let's talk about cosine, inverse cosine. I'll actually do one of the problems. Now the thing is, inverse cosine, the allowed interval is different. For the inverse cosine, the allowed interval is between 0 and pi. So if we think about the unit circle, for an inverse cosine, the possible answer for the angles are actually in this first and second quadrant. So for this problem, once again, I'm saying, let's go find an angle that when I take the cosine of that angle, it equals square root of 3 over 2. Well, I know on my unit circle, it's right here at pi over 6, and right here at 11 pi over 6. But then I realized the acceptable angles are between 0 and pi. This is outside of it. So I just have one answer, pi over 6. All right, so like I said before, we've actually been using the concept of inverse trig functions already. We didn't call them that, but that's what we were doing. Except now we're learning about it, and we're also learning about the important idea of the limitation of the final answer of your angle. All right, so that's inverse trig functions.